This video, we're going to look at factoring polynomials. In a previous video, we went through the distribution process, which means you could FOIL it or just multiply a monomial times everything in the polynomial. Well, when you're factoring polynomials, you're actually doing the opposite. You're going to be dividing out the greatest common factor. And there are multiple ways of factoring. It depends on what kind of polynomial you have. So we'll go through a few examples here and explain what method would work best in each of these situations. So factoring is undoing the distributive property. So example 1. In any kind of factoring, the very first thing I would do is factor out the greatest common factor first, if there is one. So here I have a squared b squared plus a. The greatest common factor is going to be the biggest term, or the biggest either number or variable that you have in common with both terms, with all the terms. In this case, they both have an a, but I can't take out more than one a out of the second term because it's just a to the first power. So I'm going to be factoring out an a. So a is my greatest common factor. That means, what do I have left? So if I divide both of these terms by a, I'm left with a b squared plus a divided by a is 1. And the good thing about factoring and what you have as your answer is you can always distribute to check to see if you get back to the original problem. So if I were to distribute the a times a is a squared, b squared, plus a times 1, which is a, which is what I have originally. Example 2. Here I have 3 terms. I want to look at, do all 3 terms have something in common? Well, I look at the coefficients first, 4, 16, and 12. I cannot factor out a number bigger than 4 because the first term only has 4 in there. But 4 is a factor of 16 and 12, and it's also a factor of 4. Therefore, I could factor out a 4 out of all 3 terms. And then, do they have something else in common? Well, they all have a's in it, and the fewest number of a's I have is 1. So when you're factoring out variables, you're going to go with the smallest exponent that they all have in common. So I would just factor out an a. B is also a variable, but the third term does not have a b, so I cannot factor out a b. So the greatest common factor is 4a. So I'm going to divide every term by 4a. And what I have left will be what's in my parentheses. So 4a squared b squared divided by 4a is going to be a b squared. 16ab divided by 4a is a positive 4b. And 12a divided by 4a is a positive 3. Again, if I want to check it, I can just distribute the 4a to see if I get 4a squared b squared plus 16ab plus 12a. Which, if I did 4a times ab squared, I get 4a squared b squared. 4a times 4b is 16ab, and 4a times 3 is 12a. Example 3, I have 4 terms here. I could check to see if there's a greatest common factor, but there isn't any greatest common factor all 4 terms have in common. So when I have 4 terms of a polynomial that I need to factor, I would be using the factor by grouping. And the factor by grouping means I'm going to take groups, so divide it into 2 groups of 2 terms, so 2 binomials. You could rearrange them if you want to. It all depends on, do you see common factors in each binomial? So in this case, I'm just going to keep it as is, and then I'm going to factor each binomial, and what I have left would be the 2 binomials that I would use to write my solution. So here I have 9x squared minus 3xy. I can take out a factor out of 3 in both terms, and they both have at least one x in it, so I can factor out an x. So if the greatest common factor is 3x, what do I have left? 9x squared divided by 3x is 3x minus 3xy divided by 3x is just a y. Now my other binomial, I want to make sure whatever I have left in parentheses is the same as 3x minus y. So right now I have a 6x. I need to make that a 3x. In order to do that, I'm going to be factoring out a positive 2. 6x divided by 2 is a 3x minus a 2y divided by 2 is y. My two parentheses are now the same. That's what you want to make sure happens when you are factoring these, because that will now become one of my binomials in my answer. So 3x minus y. Now to get my other binomial, it's everything on the outside. So that would give us 3x plus 2. And if I were to FOIL those, I would get my 4-degree, or my four-term polynomial. Moving on to example 4. Here I have a trinomial here, and when I have a trinomial and I have a leading coefficient of 1, I can use a method where I find two factors, two numbers that I can multiply to get our C, which is in this case an 8. But those same two numbers, if I add them together, has to give me my B term, which is negative 6. So I got to think, what are my factors of 8? So I got 1, 2, 4, and 8. So 1 times 8 is 8, 2 times 4 is 8. But I have to make sure that if I add those two numbers together, it has to give me a negative 6. Since my C is positive and my B is negative, I have to have two negative numbers. So how I would start off here would be put my sense of parentheses in here. I know both of them have to be negative, and my only variable is y. So I got to think, is it a negative 2 and a negative 4? Or is it a negative 8 and a negative 1? When I multiply those all equal a positive 8. But which one adds up to negative 6? The only solution would be is negative 2 and negative 4. Because negative 2 times negative 4 is 8. Negative 2 plus negative 4 is negative 6. So I would put a 2 here and a 4 here, because there's my negative 2 and here's my negative 4. And if I were to FOIL it, I would get y squared minus 6y plus 8. So this would be the factored form of that polynomial. And example 5, since the leading coefficient is bigger than 1, I'm going to use a method called the AC method. And the AC method just means take the coefficient or your A times your coefficient or your constant C term. So if I multiply that, that gives me 6n squared. And that's going to be my new C. So I got to think, what do I multiply to get 6n squared, but if I add them together, it gives me 5n. Well, I know that 3n times 2n gives me 6n squared, and 3n plus 2n gives me 5n. So now I break those apart, and now I bring down the sides. So this would be 3n squared plus 3n. That's one group. Bring down the 2 here. Here's my other. And you'll notice that I'm now going to be factoring by grouping like I had before. So now I factor out the greatest common factor of this first binomial. They both have a 3n in common, so I can factor out a 3n. And that leaves me with n plus 1. And over here, I can factor out a positive 2, and that leaves me with n plus 1. The n plus 1s are the same, so that's going to be in my answer. Everything on the outside, 3n plus 2, would be my other binomial. So my answer is n plus 1 times 3n plus 2. And then we have factoring special products. So here, we're going to go back to when we were working on multiplying polynomials. We had special products there, so a difference of 2 squares and perfect square trinomials. We're going to do the same thing here. So in example 6, I have 2 terms. So that means this could be a difference of 2 squares, but 6 is not a perfect square and 96 is not a perfect square. But the very first thing I want to do is check to see, can I divide out a greatest common factor? And I can. I can factor out a 6. And if I factor out a 6, I'm now left with d squared minus 96 divided by 6 is 16. So in parentheses, I do have a difference of 2 squares. So what I have is this one right here. So I want to write it like this, a plus b times a minus b. So I'm going to start with my 6 on the outside, and I have 2 parentheses. I know one's going to be plus and one's going to be a minus. And then all I have to do is take the square root of a and the square root of b. So the square root of a, so the square root of d squared, which is my a. So this is my a and this is my b. So the square root of d squared is d. So I'm going to put a d at the beginning of each one. And then the square root of b, the square root of 16 is 4. So my answer would be 6 times d plus 4 times d minus 4. And if you were to FOIL this, I would have d times d, which is d squared. D times negative 4 is negative 4d. 4 times d is a positive 4d. So the 4d's already cancel each other off. And I'm left with 4 times negative 4, which is negative 16. D squared minus 16. Multiply all that by 6. That's how we get our 6d squared minus 96. Next example. I have a trinomial where everything is positive. So I have this. This is what I'm given. I want to write it this way. So in order to do that, I'm going to write it in this format. So let's see, I have a squared term here plus 2ab plus b squared. Now I only have one variable, so I have a y here and I have a y here, and all I'm going to do is find the square root of 144, which is 12. And then I'm just, to guide my y, I just did the square root of that. And then the roots of each of these, the square roots of each of these times 2 should give me the middle term. So 12 times y times 2 would give me 24y. And now look at here. Here's my a and here's my b. So my answer, actually this is not my b. My b is right here. So now my answer would be parentheses y, and I use this sign here, plus my b, which is 12, squared. Or you could write it as y plus 12 times y plus 12. Either way would be correct. And our last one here, I have a trinomial, so I know I'm going to be using, it's a perfect square trinomial. This sign here is a minus sign, so I'm going to be using here. So this is what I have. So I have a squared minus 2ab plus b squared. So I'm going to find the square roots of 36t squared, which is 6t. And then the square root of 4 is 2. So now I just want to double check the middle term. 2 times 6 is 12. 12 times 2 is 24. 24t is what I have here. So if this is my a and this is my b, I can now write my binomial, which would be 6t minus 2. And all this would be squared. So that is how you can factor polynomials.